Hey, this is Dr. B, and let's talk about electron dot structures. You can learn a lot about an element by considering what's on its outer shell, its surface, if you will. Here's oxygen. It has 6 valence electrons. This does not look stable to me. I see an extra electron needed there and an extra electron needed there. All atoms tend to want to obtain noble gas configurations. It needs 2 more. Hopefully you can see that this is a quick and informative look at valence electrons and the chemical reactivity of anything. The noble gases are stable. Everybody else is not. This guy, if it can lose those electrons, it will have the full outer shell underneath. Lose 2, will have full outer shell underneath. These only need to gain 1 and they can become like the noble gases. So by drawing this out, you get to see how stable or unstable a molecule is. Think of it largely as just drawing a square around the substance and then trying to draw the electrons around that square, pairing up when you need to. Carbon doesn't need to at all. Have a look. See, 4 valence electrons, none of them need to be paired out. So spread them out, pair up when you need to, and you get a good look at the chemical behavior of substances. We've avoided the D block and the F block because those have unfilled inner shells and life can become a little more complicated. Let's do water. There's hydrogen, there's oxygen, another hydrogen. These can combine to form the electron dot structure for water. Now some teachers require you to write all those little dots there, but these 2 dots here are simply the shared bond. Those ones are lone pairs that you can see they're not bonded to anything. I prefer to draw it this way, it just looks clearer. If you just apply that and draw lines where the single electrons are, it can take you a long ways. Fine, we've got 8 electrons there. Each one of these has 2. Don't forget that for hydrogen and helium, they don't have a second shell. So for those, 2 electrons is enough. For all the others, they're looking for 8. Okay, let's try carbon dioxide. To draw this, I would recommend use your honk rules. Put the one in the center that forms the largest number of bonds. That's carbon. And then draw your oxygens around the side. And you should draw it like that. That's the electron dot structure of carbon dioxide. I prefer it like this. In either way, convince yourself that there's 8 electrons around every single atom. There's oxygen, there's carbon. Everybody's happy. Double bonds. Now try nitrogen, N2. It forms 3 bonds, so apply your honk rules and just draw a triple bond. You can then change the triple bond into 3 shared lines. I think I'd rather see 2, 2, 2 rather than 3 and 3. This makes it look like it's a 3 electron bond. In any event, when you count them up, life is good. 8 electrons, 8 electrons, and everything's nice and stable. This is electron dot structures.